The purpose of this video is to go over some of the commonly asked questions on the exponential functions review. The first one is 2a. This question is similar to one of the questions that you had to hand in at the end of week 1. Basically, you have a base that is a fraction to an exponent that is negative and a fraction. So the first thing we're going to do is deal with the negative exponent. So a negative exponent means that you take the reciprocal of the base, which is 16 over 81. So you flip the base, and then the exponent is now positive. You do not take the reciprocal of this exponent, only the base, to make this a positive exponent. And now you work with the fractional exponent. So the bottom number, the denominator, is the root. So we're taking the fourth root of the entire base. And then once you find that, you apply the power of 3, the exponent of 3. So the 4 becomes the root, and the 3 becomes the exponent. The fourth root of 16 is 2. The fourth root of 81 is 3. And then you take the exponent of 3. So that's 8 over 27. You are expected to write the second step here, where it is written in radical form. The final question we will look at is question 8a and b, which is dealing with transformations. You can either use the graphing method or the table method, so I will discuss both because there is a split on students who are using each method. So this first question, first thing we're going to do is identify the base, which is 1/3. So we're going to graph that. It's a decreasing function, so I will substitute in an exponent of -2 to get a y value of +9, and then I will substitute in an exponent of -1 to get a y value of 3, and then when the exponent is 0, you get that y value of 1, and then when the exponent is 1, you get y is 1/3. So when the base is 3 or 1/3, you only need 1, 2, 3, 4 points. And then I'm going to join those points together. Remember that there is a horizontal asymptote here at y equals 0. If you choose to show the graphing method, you must show this base graph. If you choose to use the table method, you must show the base table. So again, it's basically what I've already talked about and did in my head over here. I'm going to choose values of -2, -1, 0, 1 for x, and then you get 9, 3, 1, and 1/3. So that's your first mark in a question like this, the base or the base table. Before I perform the transformations, I am going to describe the transformations. You are not expected to do this unless you're specifically asked, but it is a really good habit to do. Okay, so first of all, a lot of students think that a is the base of 1/3. The 1/3 just tells us what that original function looks like. And then that base could be multiplied by a number, which means that base would then be vertically stretched or compressed or reflected in the x-axis. Here, there's no number in front, so we know that number is actually 1. So a is simply 1, which means there's not a transformation going on there. B is also 1, because we look at the exponent, what's being multiplied to the x is also 1. So there's no horizontal stretch, compression, or reflection in the y-axis. Now we look at h. H is +4. Remember, it's the opposite sign of what's going on with x. So it's x take away 4, bracket of lie. So h is +4. Some students are misidentifying that as -4, but then describing it right. So that means there is a horizontal shift or translation 4 units right. And then v is that +2, which means there's a vertical shift 2 units up. So you could be asked to identify ABHV values, and you could be asked to describe them. So now we will perform these transformations pretty easy as there's no stretches or reflections. We're just taking these points, moving them 4 to the right and 2 up. So we have those points, and then also make sure you move the asymptote up 2 as well, and that would have the equation y equals 2, and then you just join your points and hug your asymptote. So then doing this with the table method, what you would do is take the base points and you would apply the transformation. So x is affected by b and h, which I've highlighted in green. So you take the x and you divide by the b value. So here it's just 1, so you can leave that as x. And then we're going to add 4 because we take those x values and add 4 to move them to the right. So then you're going to take each of these x values, -2, and add 4, -1, add 4, 0, add 4, and 1, add 4. And then for the y values, you multiply them by a, and then you add the 2. And now we are going to multiply each of these by 1 and then add 2. So you get 11, 5, 3, and 2 and a third. So each set of coordinates, so 2, 11, you should find on this graph. 3, 5, you will find on that graph as well. 4, 3, and 5, and 2 and a third. 8b is more involved as it has a and b values. So here the base is the 2, so you're going to graph y equals 2 to the x. So here you're going to have 1, 2, 3, 4, 5 points, as all of those can fit on the graph. Remember to label the graph, and you also have that horizontal asymptote at y equals 0. So you need that base graph to get your first mark in these transformation questions. If you're using the graphing method, you need to show the base table. So you're going to choose x as -1, 0, 1, 2, and 3. And so y is 1/2, 1, 2, 4, and 8. So that is the first mark that you would get either through the graphing method or the table method. So next we are going to identify A, B, H, and V. So here A is -1. The base is 2. You have a negative in front of the 2. So you might even want to put the 2 inside brackets. So outside of that is -1, which means there is a reflection in the x-axis. Then we look and the number multiplied by x is 1/3. This is in proper form, which is the b bracket x minus h. So we have this in proper form, so we don't need to factor, but just be aware you might need to. But either way, you'll get the b correctly, probably. So b is 1/3, which means there is a horizontal stretch of 3. Remember, brackets of lies, the opposite is happening. And then we can see h is -2. Remember to take the opposite sign inside the brackets. So that means we have a horizontal translation 2 units to the left. And v is -5, which means a vertical translation 5 units down. So now we're ready to perform the transformations. So first I will apply the A and B transformations, the stretches and compressions and reflections first. So I'm going to take this point here at 3, 8. A is -1, so I'm going to reflect it in the x-axis. So it's going to be reflected, so it's way down here. Remember, right now it's 8 units above the x-axis, so now you're going to be 8 units below the x-axis. So here, another way of looking at it is the y value is 8. So you're going to multiply the y value of 8 by -1 to get -8. So it's down here. We also want to perform that horizontal stretch of 3 at the same time. So horizontally, we're going along the x-axis. So right now we're 3 away from the from the y-axis. So we're 3 out, so we're going to triple that. So 3, 6, 9. Another way of looking at it is you take that x value of 3 and you multiply it by 3 to get 9. So we reflect it to go down here, and then we are 9 away from the y-axis. So we will end up here. So the next point at 2, 4, reflect it. So it's at 2, negative 4. We're 2 units away horizontally. So now we're going to be 2, 4, 6. 2 times 3. So we'll end up at 6, negative 4. The next point at 1, 2, reflect it. So it's at 1, negative 2, and then stretch it by 3. So you instead of being 1, you're now 2, 3. 1 times 3, which is 3. So you're going to be at 3, negative 2. And then we will take the point 0, 1. We will reflect that. So we're going to be 1 below the x-axis. And then the stretch of 3, since the x value is 0, 0 times 3 is 0. So we stay on the x-axis, sorry, the y-axis. So we will be here. And then we have this one last point at negative 1, 1/2. So we're going to be a half below the x-axis. And then the x value is negative 1. So negative 1 times 3 is negative 3. And again, we're stretching by 3 away from this y-axis. So now you have your 5 points and you just join them together. Our asymptote still remains at y equals 0, but that's going to change next when we apply the horizontal and the vertical translations. So then I just took each of those yellow points and I've moved them 2 to the left and 5 down. So I did that for each, and then again I move that asymptote y equals 0 down 5, so the equation becomes y equals negative 5. So now for students using the table method, remember that B and H, when are in green, affect X. So I'm just actually going to first write down here, because this comes up a lot. So remember you take X and you divide it by B. Well, right now B is a fraction. So dividing by a fraction is scary. So just write it as X divided by 1/3, which is X times the reciprocal 3 over 1, which just simplifies to 3X. So we're just going to write this as 3x. You don't want to leave it as x divided by 1/3. You never like to leave that double fraction. Also, remember, you are stretching this horizontally by 3. So that means you're multiplying the x values by 3. So if you don't want to start thinking of fractions, just think of what's happening to x. Are you dividing by that number or multiplying by that number? And you multiply by x when you're stretching, and you divide x when you're compressing. So next we have h is negative 2. We're moving all those x values 2 to the left, so we are just going to take away 2. Then you take each one of these x values from your base table and you substitute it into here. So for the first value, when x is negative 1, 3 times negative 1 is negative 3, and then you take away 2 to get negative 5. So then I just perform the rest for each of those x values. And then for the y, which I've highlighted in yellow, a of x, y's, and v, we are going to just multiply the y by negative 1, and then we subtract 5. So again, we're just going to apply each of these y values to this. So the first one I'll do, because it's a fraction, negative 1 times a half, take away 5, is negative 1/2 minus 5, which is negative 5 and a half. And you can change that to decimals if it makes you feel more comfortable. And then do the same for the rest of the y values. And then once you finish your table, you have 5 sets of coordinates, which you would then plot and then draw your curve through. Just make sure you draw your asymptote.